Now see what is the priority scheduling algorithm. So as its name suggests, the priority is assigned by an operating system to process. So there are two approaches by using which the CPU scheduler it selects the process from the ready queue. Preemptive priority scheduling algorithm and non-preemptive priority scheduling algorithm. So these are the two different approaches. So all of you know now what is the basic difference in between the preemptive and non-preemptive approach. Learn non-preemptive priority scheduling algorithm. So what is non-preemptive priority scheduling algorithm? So at first you should know what is the meaning of the non-preemptive scheduling. Means once the CPU is assigned to the process, then that process it will exit from the run state only when it will complete or finish its execution. Yes, Shraddha. Means at first the process will complete its execution, then only it will come out or it will enter into the termination state or exit state. So that is the non-preemptive approach. So now how this non-preemptive approach is used by the priority scheduling algorithm. So in the priority scheduling algorithm, each process is assigned a priority and process with highest priority is to be executed first. So what is the meaning of this? So normally when we execute the process or whenever we create a process, operating system it assign priority to that process. And according to that priority, it execute the process. So there are different types of operating system. So in the different operating system, different numbers or different priorities are assigned to different processes. So normally the processes are classified into two types, user level process and the operating system process, which are called as system process. So normally the operating system it assigns the highest priority to the system process or the operating system or operating level processes, and it assigns the lower priority to the user level process. So in Windows, and these priorities that are assigned in terms of number. For example, if we are using Windows operating system, then in Windows operating system, the numbers which are used for assigning priority to the processes are from the range of the numbers are from 0 to 31. And in the window operating system, the highest number represent the highest priority and the lower number represent the lowest priority. So suppose 0 priority is given to the number, its meaning is that that is the user level process and that process is assigned with the lower priority. And if the 31 number it is assigned to the process, then 31 it represents the highest priority. And normally the highest priority processes are the system level processes. Whereas in the Linux operating system, this is a very important difference in between the Linux operating system, Linux or Unix, which are the open source operating system, and the Windows operating system. And if there are two processes which are having same priority, then that are executed on the first come first serve basis. Okay. So now we will directly solve the problem. Here I have written that smaller number is representing the highest priority because this is the difference in between the Linux and Windows operating system. That is, in Windows, the highest number represents, smaller number is representing the highest priority. So the process of drawing the Gantt chart is very important here. So if your Gantt chart will be correct, then only you can find out all the answers for all the times which are asked in the problem. So this is a given table where the arrival time and execution time, which is nothing but the burst time of all the processes are given. So now here we will create a ready queue and we will take out the process depending on their arrival time from the process table, and we will put that process in the ready queue. And from that ready queue, we will draw the Gantt chart. So now all of you know now how to select the process. So here we will start from the lowest arrival time. So you have to find out the lowest arrival time. So lowest arrival time for the process P1, it is equal to 0. Then process P2, it is equal to 2, P3 is equal to 1. So only one process is arrived at the time slot 0 or at time minute 0. So what we will do here, your CPU scheduler, it will pick up that process P1 from this table and it will place it in the ready. Okay. So now here we will represent the ready queue. So in the ready queue, we will show these entries, process ID, that is identification number, which is given by an operating system to keep track of that process. So normally these are the numbers But here for I for easy problem solving, here I am representing it as P1, P2 like this. But normally numbers are given in the exam. These numbers are like this 1, 2, 3, 4. So you draw this ready queue. In that here I am representing it like this, that is process ID, arrival time of that process, priority of that process, and burst time of that process. So here we are using the non-preemptive approach. That is, once the CPU is assigned to that particular process, it will exit from that run state or CPU only when it will complete or it will finish its job. Okay, so only one process has arrived at time unit 0. So your CPU scheduler, it will assign the CPU to the process P1. So we'll represent it by using the Gantt chart. So your process P1, it is starting at 0 time unit. Completion time of that process P1, it is equal to 3. So I will write down that completion time on the right hand side in the Gantt chart. So on the left hand side of the rectangle, I am representing the arrival time, and on the right hand side of that rectangle of P1, I am representing the completion time, that is 3. Okay. Now here you can observe that process P1, that is processing time, total processing time or burst time for the process P1, it is equal to 3. Now here what you have to find out here. So check out now, check out the different processes which are having the arrival time which will be less than 3. That is process less than or equal to 3. That is process P1, it has completed its task at 3 o'clock. तो आपको ऐसे processes वहां से select करनी है कि those arrival time of all those processes are less than or equal to 3. So it is P2 and P3. Yes. So arrival time of the process P2 is equal to 2 and arrival time of process P3 is equal to 1. But here you can observe that process P3, it has arrived at 1 o'clock. If I am considering it as a hour basis, then an hour basis. So P3 it is arrived at 1 o'clock and P2 it is arrived at 2 o'clock. So what I will do, at first I will select the process P3 from this table. Then what you have to do, you have to place that process P3. Yes, this thing is remaining. So your, as this is the non-preemptive approach, so process P1 is completed and it will enter into the termination state or exit state. So I will delete that process from the ready queue because it is completed now. So that process, it will not be it will not present in the primary memory, or it will not present in the ready queue or run state. So that process is completed. So because of that, that process P1 is removed from the ready queue. After that, we will pick up the process P3 from the table and then place it into the ready queue because arrival time of the process P3 is less than the arrival time of the process P2. So place that process P3 into the ready queue and then choose the process P2 because the arrival time of process P2 and P3, it is less than or equal to 3. No process is there which is having arrival time equal to 3. Okay. इस टेबल में ऐसे 7 प्रोसेसेस आर देयर एंड किसी भी प्रोसेस का अराइवल टाइम 3 नहीं है. So only 2 processes are there who are having arrival time 1 and 2. So place this, cut that process P2 from this table and place it in the ready queue. Now what you have to do here, so 2 processes are there whose arrival time is less than or equal to 3. So now here this is the non-preemptive priority scheduling algorithm. So now here we will not check the burst time. In the shortest job first algorithm, we select the process by using their burst time. But now as this is the priority scheduling algorithm, here we will select the process by using their priority number. And here in the problem it is given that lower number is representing the highest priority and higher number is representing the lower priority. So which process you will select here? Yes, so you will select the process P3. So now select that process P3 from the ready queue and assign the CPU to that process. So I will assign the CPU to that process. That process, it has entered in the run state or in the CPU at 3 o'clock. So total burst time or completion time required for that process P3 is 4. Yes, so what will be the completion time? It is 7. That is 3 plus 4, it is equal to 7. So represent that 7 on the right hand side. Okay. So now what you have to do? So as this is the non-preemptive approach, you have to cut that process P3 from the ready queue and then write down their completed, because that process it will not present in the ready queue as well as in the run state. So because of that, here I am deleting or cut that process from the ready queue and write down that the execution of that process P3 is completed. So only one process is there which is present in the ready queue now, and that process is P2, and its priority is equal to 6. So here in the Gantt chart, you can observe that the completion time of the process P3 is equal to 7. So what you have to do now means यहाँ पे आपको check करना है कि when the process P3 was executing, whether any process is entered into the ready queue or not. So for that you have to check the arrival time. See, we are using the arrival time, priority also or burst time also. So now check out that when the process P3 was executing, which process was entered into the ready queue. So you have to check that which process is having arrival time less than or equal to 7. So less than or equal to 7 कौन से process का arrival time है? So yes, it is P4. P4 arrival time of process P4 is 4. P5 का 6. P6 is 5 and P7 is 7. Yes, all the processes, remaining processes are 4 there, and all the processes are having arrival time less than or equal to 7. So now what we will do now, depending on the arrival time now, we will select this process one by one from this table and we will put that process in the ready. So at first we will select the process P4 because arrival time for the process P4 is 4. Okay. So we will place it in the ready queue. Okay. So while selecting, we are considering the arrival time. Here, while selecting the process from the table, we are considering the arrival time. We are not considering its priority. Okay, because process P4 it has arrived in the ready queue at 4 o'clock. So when the process P4 was arrived in the ready queue, that time process P6 was not there, P5 was not there. Okay, when the process P3 was executing, that time at 4 o'clock, process P4 it has entered in the ready queue. Okay, so that's why here I am considering the arrival time. When process P3 was executing at 5 o'clock, the processing of P3 it was not completed, but that time process P6 it was entered in the ready. Okay, like this. And when the process P3 was completed at 7 o'clock, that time process P7 it was entered into the ready. So when the process P3 it has completed its job, that time 4 processes were there which were entered into the ready. So now what I will do, I will select the process P4, its arrival time is 4. So cut that process from this table and enter it into ready. This process will be P6 because its arrival time is 5. At 5 o'clock, process P6 it has entered into the ready. Then after P6, P5 because arrival time of process P5 it is less than P7. So next process is P5. Then at the last the process P7 will enter. So arrival time of the process P7 is 7 like this. So now all the processes are present in the ready queue. Now no process is there which is present in this table. So all the processes are entered into the ready queue. Now here for selection criteria, now we will not use the arrival time, we will not use the burst time. As this is the priority scheduling algorithm, now we will use the priority of the process. And lower number it represents the highest priority. So at first find out that which process is representing the higher priority process. Processes are there which are representing the same priority. That is process P4 is there and process P6 is there. Okay. Now if both the processes are representing the same priority, then which process you will select here? So now process P4 and P6 both are having the priority equal to 4. So what I will do here? I will select the process which is arrived. Means I will select the process from P4 and P6 by using the first come first serve basis. So tell me now which process I have to select now from P4 and P6? P4. Okay. So assign the processor to the process P4. Okay. Though you have solved the problem, you can answer my questions also. So what will be the completion time for the process P4? By considering the, processing time for the P4 is 2. So completion time for it will be, do not get confused in between all these numbers. So it is 7 plus 2, 9. So this time we are considering the burst time. So it is 7 plus 2, it is 9. So now process, as this is a non-preemptive approach, so process P4, it has completed its job. So we'll cut that process from the ready queue and write down here completed. Okay. Now, so now represent the process P6 in the Gantt chart and tell me the completion time for the process P6. So it is, so total burst time for the process P6 is 4. So it is 13. So it will be 30 like this. So now what I will do? So again I will cut that process P6 from the ready queue and write down there complete. Okay. So now three processes are remaining in the ready queue, P2, P5 and P6, P7. So tell me now which will be the next process. Now you have to compare the priority. Do not consider the burst time. So that will be process P2 because its burst time is smaller than that of P5 and P7. So now P2 is there. So what will be the completion time for the process P2? So it is 80. So again that process is completed. So we will cut that process and we will write down here completed. Now only two processes are there, P5 and P7. So next process will be P5. What will be the completion time for the process P5? Yes. So 27. So again, cut that process from the ready queue, write down completed. So only one process is remaining in the ready queue now, that is process P7. So assign the CPU to that and tell me the completion time. So it is 37. Okay. So this is the Gantt chart. Now from this, cut that process P7 from the ready queue, write down it as complete. So this is your Gantt chart. And now you have to find out the completion time. Completion time for the process P2, 18. P3, 7. P4, 9. P5, 27. P6, 30. And P7, 37. Calculate the turnaround time. That is total amount of time spent by the process in the primary memory. That is in the ready queue as well as in the run state. That is in the CPU. So it is 3, 16, 6, 5, 21, 8 and 13. Waiting time is turnaround time minus burst waiting time for, so it is 0, 11, 2, 3, 12, 4 and 20. Okay, yes. And response time, that is the CPU for the first time, that is process your CPU scheduler. If it has assigned the CPU to the process for the first time, then you have to subtract the arrival time from that. So the CPU assigned to the process P1 at 0 time unit. Now consider the left hand side. Left hand side ka time consider karna hai. So the CPU is assigned to the process P1 at 0 time units and its arrival time was 0. So it is 0 minus 0, 0. Then if we will consider process P2, so the processor, it was assigned to the process P2 at 13 time units, but the arrival time of the process P2 it was 2. So it is 13 minus 2, which is equal to 11. Right.